Uh, Thanks, Rajan. So welcome everyone to the Practitioner's Guide to Legacy Modernization. Today we will walk you through like a practical approach to transforming legacy code bases into agile, future-ready platforms. So we have three segments to it. So we begin with a look into how AI-powered code reengineering, where Gen AI is used to convert monolithic systems into modular, scalable architectures which significantly reduce technical debt. So that's the first part. The next, we explore our test automation suite, which auto-generate test cases, validations, and synthetic data, among other features, but it seamlessly integrates into GitHub, Azure DevOps, and other CI/CD pipelines. Right? Finally, you'll see in action this through GitHub modernization demo and a second one on Boris AI, which is a merit accelerator for code reengineering and testing, right? So this hands-on experience shows how AI augments developer experience, DevOps, and also increases or elevates developer productivity in real-world scenarios. So let's now investigate how we approach legacy code modernization with GitHub and Merit. Uh, Brittany, if you can please.
Yes, absolutely. Thank you so much.
Thanks.
So I want you all to think about the oldest piece of code in your current project and how confident you might be making changes to it right now, which is probably to say not very confident. If you've ever inherited a code base with no documentation and thought, I have absolutely no idea what that does, that kind of sets the stage for most legacy systems. In the current landscape, most legacy projects are about 80% of enterprise software. The entire world runs on legacy systems, and they're usually built on outdated technologies and architectures that were designed decades ago. Makes it really hard to do things like apply security patches or make any improvements. And usually there's pretty significant knowledge gaps that are associated with those original developers who built the system no longer working at the company. A lot of the traditional approaches for legacy refactoring are kind of expensive and difficult to do. So you'll often see things like proposed full rewrites of a legacy system. They create overall a poor developer experience. Developers are spending months working on this really complex and risky project, usually coming across the same bugs that existed when the first system was developed. And it usually ends up a super frustrating experience and ends up with higher turnover in developers. Generative AI coming out has sort of changed this narrative in a really cool way. So instead of spending hours or days trying to understand what a legacy function does, you can now feed it into a generative AI system and it can tell you exactly what it does based on how it's built. It can analyze, provide a clear explanation of what it does in seconds, as opposed to those hours and days. It's really, really valuable when you're working on something that was built by somebody else who's no longer at the company. The generative AI is also resulting in much higher productivity and more developer satisfaction, which we'll get into later in the presentation. Here are some of the ways that it actually works in practice. I'm a developer, so these are the things that I do with it every single day. Code understanding, so AI can analyze and explain really complex code quickly so that you don't have to spend the cognitive effort to try to do it yourself and figure it out yourself. It's really, really good at recognizing patterns. So if there's an outdated pattern, it can suggest a more modern alternative and tell you, what you can do to incrementally improve the application from there. Reduces risk by generating comprehensive tests before refactoring. That's one of my favorite things that it does that we'll talk about in just a little bit. It can capture institutional knowledge by creating documentation if that documentation didn't already exist, and it can result in incremental modernization instead of these big bang rewrites so that you can make safer and smaller changes. I'll pass it back over to Taryn.
Thanks, Brittany. So, as we dive deeper into legacy modernization, it's important to recognize that our learning has been that simple one code conversion doesn't work, right? Like, so to give an example, we had recent COBOL to Python modernization project, which we did for like a financial institution. So, they had been doing it in-house. So they had been translating COBOL to Python using traditional code converters, but one of the key aspects which they were missing is the architecture transformation they needed. The result of using a traditional code converter was that the Python code was still monolithic, and it couldn't leverage their new cloud infrastructure. It's not built for the cloud when it converted to it, right? Another aspect was critical business logic, which is embedded in like decades of COBOL was lost, and they had no proper testing or DevSecOps practices in place, which was in line with the target platform. So what we did was we started by analyzing the entire COBOL ecosystem, like things like JCL scripts, visa files, CICS transactions to understand the architectural gaps, right? So instead of like just converting them, like there are some applications which are like 15,000 lines of complex loan processing or debt processing programs into a single massive Python script. We started by breaking them into microservices with the help of AI-enabled tools or Gen AI-enabled tools, right? So what it does is our solution used LLMs trained on both COBOL patterns and modern Python frameworks to guide the cloud native transformation. That's what we were looking at, to be cloud native as close as possible, especially on Azure. So we validated everything through our AI-powered performance analysis, like while against their original mainframe benchmarks also. So the key differentiator was that the solution auto-optimized Python services for performance, improving garbage collection, enabling parallelism, and optimizing database joins, like very complicated database joins. The LLMs also transform the monolithic code into well-documented modular Python microservices, right? We refactored everything into distributed cloud-ready services with IDE integrated assistance and full CI/CD validation. So better integration with VS Code and GitHub and Azure DevOps in a sense, right? So the result was that a true transformation and it from mainframe thinking to a cloud-native Azure architecture, very scalable, maintainable Python system, well documented, running 40 times faster than their COBOL application, not just simple syntax translation, right? So that cover. So I will just from move on to the testing aspect. So Brittany, if you can take it up, please.
Yeah, absolutely. Thank you so much. So testing, if you speak to any software development experts, testing is really one of the most important things that needs to be in place before you change any legacy system. That's really one of the best innovations that has come from generative AI. So it's really, really useful for specific things like adding new tests in an existing system that doesn't have very many. Most legacy systems are not well tested, and the lack of knowledge about the code base makes it really, really hard to go in and add tests just to make sure that things are working the way that you want them to. The AI, though, can generate comprehensive test suites by understanding the actual behavior of the code. One of the problems that I personally run into when I am writing tests for anything really is that I write the test based on what I understand about what the code does. Whereas AI systems can look at the code on how it's actually written and write the test based on how the code actually works and not the assumptions that are baked in to what I think the code does, which is actually really a game changer and has resulted in a lot of edge cases that I previously wouldn't have found. It enables confident refactoring with these safety nets in place. You can put tests in place surrounding this legacy code so that you can make sure that nothing changes or breaks in the process, and then you can incrementally refactor the code so that you can make sure that there's no downtime with that legacy system. You can refactor much more confidently without actually breaking production, which is great for everybody. Darun?
Yeah, thanks. Thanks, Brittany, for that. Sorry. So to give an example based on the AI-powered testing, right? We actually put it into practice. So the same replatforming COBOL application to cloud-native Python stack, right? Like testing was a very key challenge for us because there were no formal test cases. The documents were outdated and they relied heavily on tribal knowledge, right? So we put AI-led automation test suite. And one of the key aspect which we worked on was we started with the auto test case generation. So we plugged into the mainframe screens, auto converted them into Selenium-based UI scripts for the new app, right? So this cut down test case creation by over 90% compared to manual scripting, right? The next major important fact was the business logic was rewritten from COBOL to Python. So the code conversion testing engine validator, logic equivalence, and flagged like a lot of like almost 100% of the data type conversion mismatches, issues that would have caused a lot of data errors in production. Data dependency was another key blocker. Production data being financial was locked on. Masking was very expensive because we're looking at terabyte-sized data, right? So we used a synthetic data engine, which automatically generates test data as close as possible to the original DB2 schemas. This eliminated the need for production data, allowed us to do a lot of parallel testing. The Then came the documentation part or the lack of it. So PDF and image analysis, we reversed engineered test scenarios from old screenshots, documents, which are like primarily scanned. They were like physical printed documents which are auto converted to give us consistent coverage. Uh, so in the end, what would have taken us like 6 to 8 months of manual QA was compressed to like within 10 to 12 weeks, right? But which was accelerated a lot with AI accelerating the entire test coverage, accuracy, and delivery. So that's putting AI into practice in test automation aspects. So, Brittany, if you can take up the next second, please.
Yeah, absolutely. So now we're going to talk a little bit about what this actually looks like in practice, which is exciting. The meat of what we're talking about here. So AI is really the next frontier in developer experience. It's a really fantastic spot to be spending your time investing in developer experience right now. What you're doing when you invest in developer experience and in AI is you're equipping developers to be their most productive. It not only increases the overall happiness of most developers, but it also increases their flow and ability to stay in a state of flow. So I'm going to talk a little bit about what that looks like specifically for GitHub, which is GitHub Copilot, which is one of the world's most widely adopted AI tools. I can confirm as a developer myself that it does indeed maximize developer happiness based on, studies we've done just doing research with developers that use this day to day, increases developer productivity and accelerates software development. It's one of the most exciting tools that I think that has come out of generative AI, personally, that I work with day to day. Developer productivity isn't necessarily just about speed and making code writing go faster. It's also about reducing the overall cognitive load on developers, making them happier while they're working. So you can spend less mental effort writing code and making changes to an existing system. You can focus on the more satisfying work by saying, hey, AI, can you please go write these tests that I don't necessarily want to go write myself so that I can focus on larger architectural changes. And a lot of developers are saying that they're able to more stay in flow while they're using these tools, which is a really cool development because there's a lot of problems that have come up with overall developer experience that results in a slow code writing process. Focusing on developer productivity, like in using GitHub Copilot, means that you're focusing on what matters most to developers. So you're allowing them to focus on the more impactful changes and the more meaningful changes. Instead of typing out boilerplate code, developers can focus on solving larger problems and collaborating with their team. And that means that you can rely on AI tools like GitHub Copilot to do things like write unit tests, suggest code improvements, find the right Git command, which is surprisingly difficult, summarize code changes, and explain code overall, which is really cool. It means you're spending a lot less time on a lot of those things and more time on designing and brainstorming and collaborating, which results in overall better systems. It's also been found to be much better for enterprises. It increases the cycle agility release, which means faster writing of code, faster getting things to production, and faster delivering features to customers. Makes it faster to onboard new developers, and it also keeps developers around more often than it did previously, which means overall less expense to enterprises as there's churn with developers. So I want to show a little demo. Let's see here. There we go. Of what this actually looks like in practice. So this is Copilot chat and completions. First, what I'm doing is I'm writing tests for this test case that does not actually exist. This is in one of my own personal projects. And you can see that you just highlight the code, write /tests, and it'll generate all of these tests for that thing right in your IDE, which means No leaving your IDE to go research what's going on here. It also means that now this thing that didn't previously have tests has a lot of tests written for it based on how the code actually works instead of how I think it works, which is awesome. Now I can go create a new file and ask Copilot to generate the entire file for me. I can say, create a podcasts file that will go get, all of the podcasts in the data folder and display them similar to how we're doing with other things. Can take in a lot of the context of the surrounding application to make sure it's following existing conventions and create it just like that, which is super cool. Now, if we decide that we want to go rewrite this whole thing, you can modify it and say, I want to, or you can have it explain the existing code in case you forget and you don't want to spend the time trying to actually reason through the code to figure out what it's doing. You can use the /explain tool to go through and explain what that code does. And finally, you can use something like Copilot Chat to say, hey, we're now using Python instead of TypeScript everywhere. So you can convert this entire file to Python, which is a very common use case for legacy refactoring, is moving over to a new technology. And it can generate an entirely new file based on an existing file that will do functionally the same thing, which is incredibly cool. These are just a handful of the things that I'm personally familiar with and use day to day. There's also another tool that I use quite a bit called the Copilot Coding Agent, which is built right into GitHub. So you can see, I think this is from August 8th, 2024, is the issue that I created in my backlog that's been around for a bit. The issue prompt here, the prompt here is the actual issue in GitHub, and you can assign it to Copilot. Take a look here, it adds the little eyes and says that it's working, and taking a look at it and generates a PR. So your prompt for these things is just what's in your GitHub issue. So you don't actually have to leave the GitHub ecosystem if that's something that you're using day to day. It'll go through and look at the code, put together a plan for how it's going to actually make these changes that I probably would have never made, given that the issue was created in August of last year. And you can actually watch it as it's going. So you have this session that's running and creating a list of changes that it needs to create to be able to make the changes for you, which is really, really cool. After it produces a PR, I'm going to speed it up a little bit because you can watch the entire thing as it goes, but I do skip quite a bit of I think 5 or 6 minutes of it, because otherwise it would just be sitting here watching it spin its wheels while it's working. But this allows you also to stop the session partway through if you need to, if you see that it's going off the rails, because as we all know, that generative AI is non-deterministic, which means that you cannot guarantee that it's going to obviously do exactly what it is asked to do. So now I've gone through and skipped ahead to where it has finished creating this. You can see it's no longer a work in progress. It did all of the stuff. It added examples, it added testing and evidence to show how it tested it. And all of this was done without me ever opening an IDE. It was all done by Copilot. So now it has a PR, and I can take a look and say, does this work? See if it produces the results that I wanted and review it like any other code change. When you add comments to this and add an actual code review, Copilot will go and take that and iterate on the changes. So you can definitely chime in and say, hey, I don't like the way this is done. Could you do it this way instead? Which is pretty common. So you can say, this did exactly what I asked it to, and review the file. And then if it's approved, then you can merge it in and move on to your next task. What's really great is you can assign multiple of these issues at once, which is really, really cool. So if you have a bunch of stuff in your backlog that's been sitting there for a while, like tech debt issues or, changes that you want to make to an existing legacy system, this is a fantastic way to knock out those low-hanging fruit items that otherwise would not get prioritized. And you can see we approve, submit the PR, review, merge it, and you can see that the changes that it was making actually show up in the code base right away, which is really cool. So now I added these changes to my code base without me ever having to open an IDE or write a line of code myself. I'll write over to you, Sibram.
Yeah, sure, Brittany. I'll take it from here. Um, the Boris AI. The Boris AI is a tool which we are utilizing heavily on the testing and as well as code re-engineering part. In the code re-engineering part, we are having a legacy conversion system where we'll be converting a legacy code into a modernized architectural code, where the legacy code will have very less documentation and lack of expertise of the new joinee in the team. So considering that in mind, we have built that entire system. That entire system is totally based on a set of templates, and the templates are considered the templates like some set of prompt which is engineered in a way from a prompt factory to facilitate the conversion. And the other part is test automation suite. The test automation suite will generate test automation code, and it will generate test cases, and it can scan a PDF and it can give an accurate result of the PDF. So let us move to the demo part of this one.
Yeah, to add a bit of more context to what Shivram is saying, the demo, what we will show is based on a project we did some time back. It's primarily, we did a lot of Perl to Python migration for engineering. Uh, so, like I think almost like 400 plus but notebooks, Perl notebooks were converted to Python, and at that time, like coding agents were like not very mature. So a lot of work can still be done by coding agent, which we agree to the fact, right? And but the difference is one, this built for legacy modernization, especially for tools like Perl, COBOL to be migrated into modern cloud-based platform. The backend has a set of prompts, and the LLMs are trained specifically for the re-engineering from legacy to uh, Python or any of the other newer set of stack. Yeah, so yeah, Shivram, please.
Yeah, sure, Tarun. So as Tarun mentioned earlier, we are trying to convert the legacy code where the prompts and the sophistication level of the prompts has been mitigated with the prompt factory, where it will get into the code base, and from the code base it will convert the code, and it will have the verification. So the key thing which we want to highlight here is the testing part of the converted script. So the mere conversion from legacy code to the modern architecture will helps, but the actual agenda is we need to get the accurate result of the legacy and the modern conversion. So consider that one like a level one of the legacy verification, where it will happen automatically without any human intervention. And after once the approval has been done from the AI, it will pass to the respective developer, and the respective developer will provide the approval for the converted code. So this is a system which is totally built into traverse into the code base or repository, and to give the result, accurate result as much as possible in the conversion, testing, and the level one result, and then will be moved to the approval part. Uh, this is a visual representation of how the legacy code conversion works, and it is separated into a prompt layer, a code, and then the converted script. And the same visual tool can be used to convert a code for some niche purposes, where some of the code needs a special attention, where we need to change the architecture based on the business need, or there are some technical gaps which needs attention. So during those times we can use this um, visual tools also. So it is arranged in a very readable way, where we can give the prompt separately and we can give the code separate, and then we can get it converted. So this is about the legacy code conversion, and the main thing is it is saving a significant amount of time where it takes months of work into mere weeks. So this is the main advantage, and it is autonomous to a good extent. Yes, this is purely for the visual cues, where we need special attention for some of the code which we need to convert. And now let's move to the test automation. Let us skip directly to here. So this test automation suite is named as Boris for a contribution of Dr. Boris Besser, who gave a significant contribution in the testing, consulting, and shaping up a modern testing fraternity. And this tool consists of many functionalities, and I'll highlight the important key functionalities. So the first functionality which we are going to check here is automated code generation, where we have to just pass a URL and then start recording it. So once start recording it, will be greeted with the browser and inspector, where we can record our macro activity. So macro activity means, what I'm trying to tell here is a simple workflow or a complicated workflow. It's up to us how we want to segregate it. It will act accordingly based on our business needs or application needs. So here we are trying to record the macro, and once done, get back to the application and then just hit stop recording. And all the processes are automated. The code will be completely fetched from the playwright inspector, and then from the inspector it will be transferred to the application. So from the application we can capture the code which has been generated, and this code is having a 1:1 accuracy, and the same code can be converted into manual test cases also. So this idea is for the projects which is having very less documentation, or they are in a very tight deadline, or they are into a development of a POC. So considering those in mind, these manual test cases will directly get generated from the code which we have recorded earlier, or based on the macro activity. And the same code can be converted into the desired programming languages. Here, the programming languages are Python, Java, C Sharp. And here I'm taking Java as an example, and we are translating the code directly from the generated code. So the accuracy will be close to 1:1, or we can tell that almost 90% of accuracy with a small lookup on, or we can totally use the code also. And again, this code is based on the framework requirement, and this is a straightforward conversion. And in the prompt factory or the prompt template, we can tailor it based on the project needs. And this tool consists of a minimalistic editor, code editor or IDE, where we can execute the generated code and we can verify it on the go. This is for the folks who are not having any environment configured, or they want to verify the code immediately which it is working or not, or should they have to regenerate the code. So yeah, here the code is working perfectly fine. And then we are moving to the next part of the tool, test case generator. So this test case generator will directly connect to a project management tool, and all we need to do is just pass the credential and a token, and then from the token we can directly access the content from the project management tool. Here the project management tool is Jira, and we are trying to connect with the Jira, and this is the use case which we are going to convert into test case with the help of AI. So yeah, do an authentication, and after the authentication will be displayed with the project, and then we are fetching the user story of the particular project which is assigned to the credential, and we can give multiple user story and start generating test case, or we can go one by one. We can include subtask also. For right now, for the time consideration, let us not get into subtask. We'll generate the test case directly from the fetched user story. So the test cases has been generated, and it has been designed in such a way like generate a 10 positive test case and generate 10 negative test case, along with the sample code which reflects the behavior of the user story, and it is totally optional. We can take it as an example, or we can develop it right from here for the automation scenarios. And the same generated test cases can be downloaded as a document in local, that is for total convenient purpose. And the generated test cases can be attached to the project management tool. That means we can attach the generated test cases directly to the user story also from the tool itself directly. So here what we are trying to do is we are trying to cut out the non-functional time which consumes which get consumed during the writing of manual test case. So here we are trying to cut out as much as possible. And if you see here in the user story, the attachment will be displayed in the attached section. So we can use it directly, or again, we can repeat the process. So it is up to the automation engineer or test engineer who is working on this tool. But the main key agenda is to save the time in a productive way as fast as possible and to get the good accuracy from here. And one more feature is we are having an admin dashboard where managers or stakeholders who are orchestrating the project can have a look on the project idea, what is happening in the project, and it will show the reflection of the test management plus along with the generated test case for the respective user story. And we are having a small statistics of total test cases, I mean, a total user story, and then the most used, least used in a text way, and then a histogram way, in a graphical way. And so moving to the last part, there are so many features in this tool. And here I want to again highlight about that PDF, which I spoke earlier. The PDF, there are two types of PDFs which you are processing. One is a complete text-based PDF, which works totally on the RAG technology, and then multimedia PDF, which works on OCR and Vision. So I'm selecting the PDF here. And this is the PDF which I'm going to take, and I'm going to directly ask about who are the authors of this PDF. So once the PDF has been dropped to the application, it will start processing, and this is a background process. And once the background process has been completed, we'll be asking the question like, who are the authors of this PDF? So this is to just to demonstrate how much accuracy we can achieve with a PDF of a decent size of 86 to 100 pages, where some of the projects the accuracy is a key factor. So once the response gets generated, we'll be shown with the authors who contributed to the PDF and along with some additional information. This is mainly due to the configuration which we did for the A based on the temperature adjustment. And if we reduce the temperature, we'll be getting the one-to-one result as accurate as possible. And this is about the text-based PDF which we want to show. And then after we'll move to multimedia PDF. So in the multimedia PDF, we will be processing the PDF into a set of images, and from the set of images, we can utilize the pages. I mean, we can get the information out of the pages by OCR and Vision. So let us move to some of the pages where it will have a set of text and some images. Let us take this image as an example. And here I'm going to ask uh, what the figure 5a is telling about. And again, so yeah, here. So once we got the result, it will accurately tell what is happening with the figure 5a, but along with some other more information because of the settings which has been done for the A. This can be again significantly reduced means that response, that overwhelming response can be reduced and shrunk down to based on the temperature settings. Tarun, over to you. Thank you.
Yep. So thanks, Shivram. So that concludes the demos, and thanks a lot to everyone who joined. Thanks, Shivram. Thanks, Brittany, for the demo. If you have any questions, you can drop in at the chat, or if you have like any more questions or like wanted more details around GitHub aspects of it or the Boris aspects of it, just drop in an email in this email ID, and we'll be more than happy to address it. Again, thanks a lot.